Hi everybody, it's Mrs. Dinkelman and I am here to talk about the notes for 3.1, which is the chain rule. So first they want us to do this derivative of x cubed minus 3 quantity squared as a product rule, since it really is x cubed minus 3 times x cubed minus 3. So we'll do that really quick, and then I'm going to simplify it in a way that I will be able to kind of show you that this chain rule actually does work. So for product rule, remember we go first times the derivative of the second plus second times the derivative of the first. And there's a couple things we could do here, like we can factor out really the x cubed minus 3. I think this is the easiest way for me to think about it, at least. I know we could factor out the other way as well, but. And then what we're going to have left over then is a 3x squared from each of these terms, which is the same as saying we have an x cubed minus 3 and we have two 3x squareds. Okay, and the reason I want you to notice that is, okay, certainly the x cubed minus 3, we see where that comes from in the beginning. The 2 is really that exponent right there. So if we had a bigger exponent, we probably wouldn't want to do product rule if it was a bigger exponent. But that's where that comes from, that too. And then the 3x squared is really the derivative of the inside of that. Again, the derivative of the inside is 3x squared. So you can see here that there's a couple ways to talk about what chain rule is. And my favorite one is really just this first one with like it looks like a composite function here. But then I also like to use some words just like I've been using with the product rule and the quotient rule. And I'll say these out loud. So for the chain rule, let me tell you what the words are that I will say. So chain rule, I'll say the derivative of the outside function. I better have better handwriting if I'm going to write it that way. Okay, derivative of the outside function leaving the inside alone and then times the derivative of the inside function. Okay, so let me say that out loud again. It's the derivative of the outside function, leaving the inside alone, times the derivative of the inside function. So you can see here that we're talking about something that has maybe an actual function on the inside of parentheses or a radical or something like that, and then also something different on the outside. And the problem with taking the derivative of those is we have to treat the inside and the outside. We can't just do them at the same time, okay? So for example 1 here, for our derivative, so the derivative of the outside function is really this exponent that's on the outside. So that's how we take care of the exponent. And then by chain rule, it says leave the inside alone. And then times, I'm going to take up some space here, times the derivative of the inside function. So that would be 9x squared minus 5. So we know that there's probably a little simplifying that we could do in there, like multiplying the 4 times the 9x squared minus 5. But for today, if that's how far you get, I'm pretty happy with that. To me, simplifying is if we need to take some extra steps. Okay. So let me erase that one so I can get to number 2. So in this case, the inside is the 3x and the outside is the sine. So let's figure out what's going on there. So derivative of the outside function, so derivative of sine is cosine, leaving the inside alone, times the derivative of the inside function. Okay, so we could probably put that 3 out in the front. In fact, a lot of people will do that after they've gotten pretty good at chain rule. They'll kind of start simplifying while they're thinking about it. Okay, on 3, before I start, I'm going to rewrite that just with one big exponent. So use the 1/2 and the cubed. So this is really the same as 2x squared minus x to the 3/2 power. So now, g prime, derivative of the outside function. Okay, when we subtract 1 from that exponent, we'll get a 1/2, leaving the inside alone, times the derivative of the inside function. And let me just make a quick comment about parentheses here. What I have here, the 4x minus 1 in parentheses, that is really important. That is different than if I don't have parentheses, because what that means is I multiply times 4, and then at the very end I subtract by 1, and that's not what I mean to do. I mean that the 4x and the minus 1 are really multiplied there. Okay, number 4, I wish we would write this differently, and in fact, if we were to type this on our calculator, we would need it to be written differently. So cosine squared really means cosine theta quantity squared on the outside. So now let's figure out what we're going to do for the derivative. So derivative of the outside, that 2 is going to pop down, becomes a 1, leaving the inside alone. So if you don't want to put that 1 power there, that's fine. And then the derivative of the inside is negative sine. So again, a little simplifying we could do there if we wanted to. Number 5, I'm going to rewrite again. I could do quotient rule in the form it's in, or I can change it to having a negative 1 as an exponent and then do chain rule. So that's a choice that you're going to have to make as we go through these. So derivative of the outside function, again subtract 1 from that, leaving the inside alone, times the derivative of the inside function. So that's just a 2. Okay. On number 6, we're going to have to do a little bit of product rule here as well. So let me just rewrite this so it's in the form that I want to think about it. So 3x squared, and then we have 9 minus 4x squared to the 1/3 power. Okay, so product and chain in the same, because sometimes that happens. So when I go first, times the derivative of the second. So the derivative of the second is the one where I need to use chain rule because there's a 1/3 on the outside and stuff happening on the inside. So let's see. First, and then the derivative of the second is going to look like, okay, 1/3, then subtract 1. So that's the derivative of the outside function, leaving the inside alone. And then times the derivative of the inside function. Okay, so that really was first times the derivative of the second, plus second times the derivative of the first. And again, for today, I would just leave it like that. Gary's answers probably simplify a little bit, but you just want to double check that you have what he has, basically. All right, and this one, number 7, is really like chain rule in the chain rule. So there's several functions here. So again, I want to rewrite this. We have to think of chain rule as working from the outside in. So when I find this derivative, the very outside thing is this exponent to the 3rd power, right? So I do the derivative of the outside and I leave the inside alone. Okay, so now I have to work on the inside. Derivative of the inside, well, the derivative of sine is cosine. And again, I'm supposed to be leaving the inside alone. And then finally, I can take the derivative of the 4t squared, which is 8t. So again, think about working from the outside in. First, take care of the cubed, then the sine, then the 4t squared. So cubed, we took care of the sine, and then the 4t squared. Okay, and then sometimes we have to do these from the table, and they're kind of helping us to do what this note is saying. You must quickly learn to distinguish between chain rule and the product rule. So product rule, even though they don't always use that time symbol, is really 2 separate things multiplied together. Whereas chain rule, letter B, it's a function inside a function. Now we're sort of used to parentheses meaning multiply, but that's not what this means. That does not mean P times Q of X, that's P of Q of X. So Q of X is living on the inside. So we do have to make sure that we can distinguish between the two. So on A, let's find f prime of x first. So that's going to be first times the derivative of the second plus second times the derivative of the first. And then if we're finding f prime of 2, we'll have to plug our 2's in for all of those. Okay, so let's look at the table and see what we can find. So P of 2 is 5. I'll see if I can sneak, well, I'll go under here because I don't need that part. Q prime of 2 is 6. Q of 2 is 3, and then P prime of 2 is 7. So it looks like we have 30 plus 21, so 51 for A. And then for B, this is chain rule, so we have to go with the derivative of the outside. Okay, that's what it looks like symbolically, leaving the inside alone, times the derivative of the inside. And now we're finding H prime of 2. So that's going to be P prime of Q of 2 times Q prime of 2. Okay, we're going to have to do a couple steps here. So Q of 2 is 3. So that now is going to change to a P prime of 3. And Q prime of 2 is 6. Okay, and then back to the table, P prime of 3 is 8. So 8 times 6 is 48. Okay, so if you can just remember to think about that derivative of the outside, leaving the inside alone, times the derivative of the inside.